Hi, my name is Gabriel Flowers,
And my name is Laila Evans.
and our project is what elements occur naturally in fusion reactions.
You might wonder why this question is important. The answer is fusion is an essentially inexhaustible fuel source for energy production. Fusion occurs in stars. However, we cannot directly observe fusion reactions in stars. So how do we know what stars burn in fusion reactions? So we can mimic it on Earth to produce energy. Using spectroscopy, we can identify each different element being used in the solar reactions. This allowed us to identify what each different light we tested was using or burning to produce the light source they had. Now, how does all this correlate to fusion, you may ask? Using spectroscopy, we identified the elements and had the ability to figure out what was burned.
The purpose of our project is using a spectrometer we can establish what elements are naturally burned in fusion reactions within stars. If the stars use hydrogen instead of another element such as lithium as fuel for their fusion reactions, then hydrogen might be a better fuel source in reactors.
Our control is an incandescent light bulb, our independent variable is a spectrum measure, and our dependent variable is a spectrum that represents the measure.
Nuclear fusion is a process where light elements, nuclei, fuse together to form heavier elements, and substantial energy is released in the process. This is safer for energy production because there is no runaway reaction such as those involved in fusion's counterpart, fission. Fusion can produce virtually unlimited energy with few dangers.
Comparably, fusion's cousin fission has had 3 famous accidents, including the 3 Mile Island with no casualties, Chernobyl with 31 deaths, and Fukushima, which is attributed to a tsunami. The more common energy source with coal reports roughly 13,000 deaths annually. Fusion will be safe and highly productive.
Procedures. First, we set up the parts and areas and gather the light sources. We then placed the phone with the app running inside of the box and gathered the spectra. We then compared it to a chart to see the difference between the spectra on specific elements. If you look at the middle of the screen, you can see a chart showing spectrums for elements like xenon. We got our data from 4 light bulbs, a warm-colored, cool-colored, incandescent, and blue neon. A warm-colored light had sodium. The cool-colored light had iron. The incandescent had carbon, and the blue neon had, of course, neon.
The hypothesis was confirmed since after collaborating our spectrum to find several different light sources, we observed a light spectrum corresponding to a hydrogen when looking at the sun. This shows that we have the ability to mimic nature, since hydrogen is an abundant on Earth that can be used for fission fuel. In the future, we would like to expand this beyond just the sun. Looking to other stars would yield more data to learn what gases are most commonly burned in natural fusion reactions.
I'm Gabriel.
I'm Laila.
And we appreciate your time.
Thank you for listening.